Hello, good afternoon, everyone. Thank you for being here. I'm Nanucci from WESCO. We are distributors, and here with John.
Hey guys, John Caselli from WESCO. I'm on our wireless team, so we'll introduce a little bit of ourselves. Let me pull up the agenda here, but we appreciate you guys spending a few minutes with us. Hopefully everybody's having a good show.
Well, for starters, the group where I work, it's mostly AMI in the public power space. So when we prepared this presentation was about public power space and how we can help transitioning from legacy networks and legacy systems to PLTE networks for AMI system and other applications. So we have been developing PLTE in other spaces on our communications and security solutions, industrial applications, and our EES solution. But we are just starting on the utility space with the type of network. So with that, we're going to start doing kind of like a historical review of not networks but communication links. Because if you go to the utilities, what we see in the last 10, 20, 30 years, there was always a communication link to do a function. So for example, you have water pumps, remote water pumps that you need to start. And back in the days, you used spread spectrum, radios, VHF. And there was a team controlling those communication links that were not exactly networks. So moving forward, you can move the slide, please. It's there. So if we go to the copper base history, you have power line carrier for AMI, you have modem for communication, certain substations or certain equipment, serial buses, and even just simply copper wires. That was the function. And essentially different groups control different communication links. So if we go to the wireless, you have the old spread spectrum, microwave links, different type of wireless application, VHF, to do load controls back in the 60s, 70s, and still today, there are systems out there working with VHF to do load controls. So essentially, when you go to the utilities, what you see is something like this image, you know? If you go with small public power, a mid-sized public power, in any place in the US, you'll have different substations connected with fiber optics. In some cases, not even connected, just a modem. You'll see that in the main building, on the main office building, there'll be a VHF tower to do the radios and push to talk or to get to certain devices. And the same tower will be used to communicate with the trucks or the load controls. And utilities with just a little bit more technology, you start seeing communication links, radio links to bridges that go to the relays that operate the capacitor banks or reclosers. And from some of those substations, you'll see a PLC network, like the one in the end, that goes to meters. So still today, just to give you an idea of the public power space, there's still today utilities reading electromechanical meters by hand here in the US. And in the other side of the spectrum, you have large utilities that are doing private LTE up to the last device. So we have what we call just move the one, what we call the utility evolution curve. You have these public power utilities in all places of the curve. From the very bottom, where you have these tiny communities reading meters manually, to here, big cities with large IOUs. And the thing is, how you interface with those utilities and all points of the curve and help them move to the new technology in a way that is affordable and convenient for them. So with that, what we do is we think about this as past or present state and future state, what we see. And today we see in utilities different groups executing different functions and different communication links and not in a network. So those groups now are colliding into what we call OT and IT, and in the end, we're going to see a single network and all the functions perform over that single network. So our role is, as a distributor and technology transfer agent, how can we help those utilities evolve from here to there? And here I will pass to John to start talking about OT and how this OT and IT have been merging, and we get to this point in which we are in a position to help these public power utilities.
Thanks, Hernan. So I think by way of historical explanation, why we want to do that is, as we look at building out a robust private LTE or private cellular network, because we're going to focus on LTE, but 5G is a part of the equation, right? A future state, as evidenced by the last talk, if you guys are around for that one. But we can think of loading these different communications platforms or communications links that we had in the past as simply applications of that network, right? So what we want to do is list, think about those applications, and then each of those has those separate engineering concerns, which we'll load into here a little bit. But the network is really a tool, right? And so the best way to conceptualize this, and I come from a world where we talk a lot about operational technologies and IT meeting within the in-building space. And the best way to think about OT for me is this really amalgamous, ugly-looking sort of thing that's difficult to control, right? Like old school voltage relays or serial buses. IT doesn't deal very well with that. IT is very used to encapsulated, packetized data that's consistent and in both size and character, right? So IoT, as the convergence of those two in some sense, really is the packetization of that operational technology data, right? And in a lot of senses, that's one of the things that we're solving for, and one of the challenges we're trying to overcome by implementing this private LTE network, right? So we'll highlight a couple of the applications that we've seen and have explored within the private LTE space or private 5G space. Now, these aren't exhaustive. These aren't applicable necessarily to every one of the utility customers out there. But we've seen, and hopefully as the last couple of days of the show have shown you folks, that these are some of among the top concerns, one of the major drivers or set of applications that we're solving for, right? So to enumerate them, we'll talk a little bit about SCADA. We'll talk about how to load fixed wireless access in there. There's some push-to-talk considerations. There was a talk I saw on the other stage that unfortunately I missed, but looked like they centered around a little bit more detailed mission-critical operations there. We'll gloss over public cellular. I know that's not the focus here, but anybody who attended last year saw that really as a bridge to some of just standing up a private LTE network, right? So as you look at the applications and you decide, okay, I want to load in push to talk, I want to load in SCADA, and I want to load in my fleet devices. As you do that, you may not be able to build that network and have it operational on day one. So some of the routers and gateway devices that you have could run on a public network as a standalone, as a transition point. And then, obviously AMI, the demand response, load control, DERMS, and condition monitoring we'll highlight a little bit as well. So Hernan, I'd like you to go over this slide too. I think this is one of yours, but
yeah, we're showing here is we talk about past state or the present state in which these public power utilities use all these legacy communication links and functions, and this is the future state, how we envision the system will work in coming decades. It's just one network, cellular, and operating over all the systems and functions. And that creates new challenges, how the different teams need to collaborate to make that network functional for everyone. the pace in which you're going to onboard new applications and the cadence and how you're going to manage and make the system work seamlessly. So what we envision is a transition from all those legacy networks and communication links to this one, and we are ready to help along the way.
So as we dive a little bit into the actual SCADA applications over the private cellular network, SCADA, I guess it doesn't necessarily mean a lot of things to a lot of different people, but there's a lot of facets to it, right? And so as you say, okay, we want to do SCADA, we want to do it over our private LTE network, we're going to build a network for that. Well, what are some of the immediate concerns, right? So as you look at what parts of SCADA you're trying to load in there, some of the ones that stood out to us and what we've been asked about it in the immediate past have been smart grid automation, real-time monitoring and control and response, fault detection, outage management, which feeds into a lot of those, and then advanced metering, right? So as you look at smart grid automation, what you're ultimately trying to do is have an immediate response to critical events, right? And ultimately what the hope is not only does the private LTE network in some senses provide a communication pathway for that, but as you advance into the further Gs, right, 5G, 6G, however many Gs we're going to get to in our lifetimes, that there's some intelligence built into that network, right? So 5G ready networks can be built today, but then 5G really takes advantage of a lot of the mobile edge compute. And as some of the keynotes Tuesday told us, that we're really looking to load in a lot of automation, a lot of AI response into that mobile edge compute, right? So what we'd like to do is start to generate data, start to generate it quickly and put it onto a network that supports those applications, but ultimately we need and want to do something with that data, right? And the closer we can have that sort of evaluation and response to whatever it is, right? In this case, smart metering, outage applications, line control. That's what we're ultimately looking for, right? And private LTE presents a lot of interesting ways to do that. So I've got some highlighted up there on the screen. I picked these because they had some more data to find on them. But ultimately, the consideration you're looking for when generating, or engineering the network is what is the response time you're looking for. Latency is going to be key in a lot of these applications, right? Hence the mobile edge compute, right? So the closer you get something to somewhere, compute it and get it back, that's your latency, right? So leveraging those low latency communication networks significantly improves grid reliability. It can reduce outage response times, outage durations, and really once you have this network up and going, there's only a minimum investment to get to any point on the grid, right? So let's move, I think, to the next one. So this is the SCADA system as it sits now, right, Hernan?
Yeah, this is what we normally see today. We have different communication links. It could be a mesh, it could be fiber, and communicated with different relays and all the suite of software that we have in the utility, not only the SCADA but AMI and the connection and interconnection between the SCADA and the AMI software. So what we envision is this moving to a scheme similar to the one we previously see. This just all center around just one network and not different type of links going to the same platform. So this is what we see as a future state in which it would be only cloud-based software and one network operating over the different sensors and devices on the field.
All right, so we'll move a little bit to a new application here. So one of the ones I'm asked quite a bit about outside of the utility space, more in the industrial manufacturing or industry, is how do we move fixed wireless access over our private LTE network? I think that, I don't want to say it's relatively trivial to solve, but the wireless communication paths are already there, right? So what we're trying to do in this is augment or supplement the existing fixed wireless access network and potentially then even replace it if that's, if that makes sense for the networks as they stand. So fixed wireless access, if you guys aren't familiar, is we always think about our mobile phones. They go on Verizon or AT&T's network. T-Mobile has, if you watch NFL football, has all those ads. That device sitting in the windowsill with the dudes from Scrubs singing about it. That's T-Mobile's fixed wireless access, right? It's internet provided from a tower down into a single. I guess in this case, a single device that is non-mobile. I mean, I guess probably doesn't bear repeating, but that's what we're talking about, right? So private LTE is well suited for that. So we have in doing that and loading that as an application for the LTE network, it's a dedicated connectivity for the infrastructure. So fiber provides a significant amount of bandwidth, a significant piece of your network. Copper will as well, but in this case, when you can't trench fiber either due to geographic terrain, cost analyses, wireless is the way to do it, right? And so we think about this as one of the other applications that really holds out well. And you can really put any other edge device on that sort of fixed wireless access network as well. The performance is going to be in the millisecond range, right? So 5G provides your 1 or sub-millisecond latency, but this would be very, very well suited for security cameras, access control, light monitoring, anything that you could put over a microwave link now, we could load onto there as well. So in defining some of the other considerations that we have for a private LTE network, as we think about which applications we want to load onto that network and what are the considerations, we need to define them as either mission critical or operational. And those are my terms. Each utility may have a different way of segmenting these, perhaps into more than 2 segments. But really what you're trying to do here is establish a quality of service paradigm. So we'll get to mission critical push to talk in a second, but if you decide that that's one application of the network, you can't buffer live human voice, right? Your SCADA demand control, load controls have to have priority over something that if you're reading meters, perhaps every 15 minutes is a good time frame to read a meter. If you miss a reading, that's probably okay, right? But if you've got somebody out in the field, there's a problem, there's an issue, and it really requires an immediate response, you want to make sure that those applications are prioritized over the other ones that are a little bit less mission critical, right? So hence the mission critical versus operational. They're all important, right? They're all friends on the network, but some are more important than others, right? Little 1984 for everybody. And the goal is really to differentiate between those two, right? So there's data that without which we would see harm. Again, that's your mission critical data. Now, in that, a lot of what we are also looking for the private LTE network to do is provide an audit trail for us too, right? So the mission critical data, whether it's the actual voice recordings or data points from the SCADA networks, those are going to be logged. They need to be able to be audited. And so we need to have data redundancy and backhaul those into a data center. We won't really get into on-prem or cloud in those applications, but those are additional applications or considerations of the network. Do you have anything to add?
Nope.
No.
This is your area of expertise.
All right, we'll pause in a second, see if there's any questions maybe midway through here. We're going kind of quick, but push to talk is one of the more intriguing, I think, applications of private LTE. It's certainly set up well for it. LTE as a technology is certainly well suited for mobility, which push to talk requires. And the good news that we have going for all of us is that everything is driven by the 3GPP standards, right? So you can pick a standard, whether it's Rev 15, Rev 16, Rev 17, in one of the subdivisions thereof, and implement that. And you can be assured that any device that you go pick up from our friends over at Motorola or Kenwood or L3, as long as it fits within that 3GPP standard, it's going to load onto that network. Some of the immediate or the extra features may not be available, but the basic functions are going to be there, right? So as we look then and say, okay, well, push to talk has been around for a very, very long time. How is that quite different from our VHF or UHF LMR radios that we're using. This is how you implement it into the LTE network. You make it mission critical. Becomes the top priority on your network. But the good thing is with LTE, you've got a lot of bandwidth depending on your spectrum holdings, and you're actually able to layer applications on top of that, right? So we see mission critical data, mission critical video. We're seeing a lot of first responders in major metro areas start to have over-the-top applications on their LMR radio using LTE, right? That was kind of one of the ideas or driving forces behind the FirstNet authority that's been around now for 20-something years or so. So again, quality of service, priority, preemption, that's going to be crucial in setting up, engineering your network and understanding the parameters that you put into the core to allow that to happen, right, over your other applications. And then along with that, if as long as you have a GPS signal available to you, you can really do some really cool things with location data-based services, whether it's geofencing or if you've got devices that you just want to know, hey, where are my guys or how are they responding if there's an incident. They're able to push to talk or get a call out to a talk group. You're able to geolocate those with the right setup, of course, right? Yeah, well, I guess one of the other things worth noting, and we got to the edge of my knowledge of SCADA on it, was really integrating some of the SCADA data or parameters into push to talk, right? So if you've got folks out in the field who are responding to an incident that the SCADA is providing data on, how do you feed that data back through the same network, right? So rather than, as Hernan said, you had disparate networks where perhaps the SCADA data is going to a central command center, somebody has to extrapolate or interpret it, get it back over the radios to the folks out in the field. This allows a pathway straight through the network in order to do that. So let's do this. We've got just a couple more slides, and that was the highlights for the applications. Did anybody have any questions specifically about the applications or the implementation on the networks?
Or also as well an opinion on the path forward for public power utilities in regard to adoption of PLTE, because this is brand new. It's something that's, although it's very old for certain utilities and users, is not that new for public power. So any opinion or question, more than welcome.
Silence is golden. Yep. So probably one of the largest considerations, budgeting, right? So it's interesting in that this is really a feedback loop in some ways, right? So you decide on what applications you want to load onto your network, what geographies you need your network on, then where do you go? Well, at that point, you're looking at spectrum cost, spectrum holding, and then what existing infrastructure do you have? So that's where we started, right? So that's one of the ways that WESCO can certainly help as a utility or customers looking to build out a network, is really helping evaluate the infrastructure costs. As a materials distributor, one of our core competencies is to ship boxes or packages, items, and do it relatively well across rollouts. But what we can help and what our partners are able to help with is helping to estimate those infrastructure costs, both from a capital standpoint. We've got partners that will operationalize or finance any sort of long-term rollouts that may be needed, both from an actual material standpoint as well as the labor, the implementation thereof.
And what we envision is a list of use cases that the utility can put together, and from those use cases we can analyze and go to a roadmap and build a roadmap. This is the network deployment. This is the first use case we're going to onboard, and from there we can go to a budget and a multi-year planning of your deployment. And we can do that first because we are an aggregator. We are a distributor, and we have access to all the components that goes into a system, even from the nuts and bolts on the tower and hardware that you need, up to the software and all the other components. So as an aggregator, we have that ability. Second, we are technology transfer agent. Every time we talk to one utility and then to another and then to another, we cross-pollinize and cross-communicate with different examples, so we have a wealth of information that we can share. So we as an aggregator and a technology transfer agent, we can help any public power utilities evolve from the technology where they are, the way in which they're doing communications, to what we believe is the future of communication in the utility space.
And as I mentioned, also not just within the utility space too, right? So we have customers in really every segment of both industry, commercial customers, enterprise, I guess. Mining, really, any vertical you can think of, and many, if not most, are looking into how you have private LTE to implement into their systems, into their business, right? And it's got to be a core implementation. It's not something that can just be done relatively quickly or willy-nilly. So the other major concern, since I mentioned spectrum already, was ongoing maintenance and operations, right? Should be no surprise for utilities. They're very asset heavy. One of the things that we see as a resource aggregator is that public power, rural co-ops may not have the financial wherewithal to bring in a lot of, wireless expertise under their own umbrella, right? So one of the things that we look to do is to strike a bunch of partnerships so that somebody can say, well, hey, WESCO, I need help building out this network. I've got somebody who can stand up towers. We've got a group who knows how to install things on said towers, but I don't have somebody who understands how to set up an EPC core, how to make that 5G ready, and how to really prepare my system. And then once I do that, what do I do with that, right? So RF is a strange beast. It's a living, breathing thing out there in the world. So you can have a tower, you can have somebody build a building right next to the tower 5 years from now, and that tower will operate differently, right? So how do you respond to that? How do you plan and make sure that all your edge devices continue to connect to the network in the way that you'd planned for, right? Which brings me to edge devices as one of our last topics here. The cool thing is you have a lot of these applications that are very valid. One of the things that manufacturing is looking to catch up with is that there's a lot of these devices that are not native to whatever spectrum you have, right? Whether it's the Anterix band, band 48 for CBRS, other licensed spectrum that you may have. And so one of the things that I delve pretty deeply into is the world of gateways, routers, bridges, whatever you might want to call them. And they all, there's some overlap, but there's a difference between each of them. So we have a very robust selection of those now for any spectrum that you might have and any device that you might need to put on there. So there are some considerations with that. That's another device to manage. It is another cost that goes into the network. It is an additional point of failure. But ultimately, as you look at those and think about some of the device ecosystems you have, some of the growth paths of those devices, where ultimately is that going to lead you? And ultimately, is that going to get your network to where you need it to be, into the future state you're looking for? All right, we touched a little bit on this. This will be our last slide here, so we'll take any more questions afterwards. But really, from a general resource point, there's a lot of knowledge about LTE in the world. It is sort of an esoteric device, and it's been kind of under lock and key for a long time, but it's a standard, right? So what I would encourage everybody to do if they're looking to understand this, just like this event is centered around doing, is to reach out. There are folks who are looking to run these networks. That's their passion. That's what they do. And so you don't have to reinvent things. You don't have to necessarily forge partnerships that are going to be painful for you. There are folks out there willing to help who really do understand these. They understand how to set up everything, and they're looking to partner with you folks. So any questions? I know we're a little bit ahead of time, pretty significantly here, but I think we got across what we were looking to do. But would welcome any questions, thoughts, comments, concerns. Bets on the Ravens game tonight? Awesome. Well, thank you guys. I appreciate you being an audience. Hopefully, UBBA the Plugfest is going well for you guys. It certainly has for WESCO. So thank you.